in this question, we're going to apply Lagrange multipliers to find the maximum minimum value of this function in 3 variables. First of all, you need to set up the gradient of f equals to lambda gradient of g. So remember that if you have ln of u, the derivative is u prime divided by u. So what we learned in calculus. So here on the left-hand side, the gradient of f is the ln of x squared plus 1, which is 2x over x squared plus 1. Then the gradient continues for y and 2z over z squared plus 1 equals to lambda. And here you have the gradient of g. This is the constraint that we have. It's 2x, 2y, and 2z. Okay, let's set this equal to each other. You have 2x over x squared plus 1 equals to 2 lambda x, the very first fraction, and the second fraction, 2y divided by y squared plus 1 equals to 2 lambda y, and finally, the final fraction, which is 2z divided by z squared plus 1 equals to 2 lambda z. Okay, so you should be asking, what if lambda is equal to 0? What if lambda is equal to 0? If lambda is equal to 0, what happens here? All of these fractions have 0 on the right-hand side. 2x divided by x squared plus 1 is 0, so 2x, only the numerator is equal to 0, so x becomes 0. The same for the second fraction. 2y becomes 0, so y is 0. And the last fraction, 2z is equal to 0, so z becomes 0. So what happens if x, y, and z are equal to 0? Take a look at your constraint. Then you have 0 squared plus 0 squared plus 0 squared minus 12 equal to 0, which says negative 12 is basically 0, which is contradiction. So this can't happen. Okay. We know that lambda is not 0 because we cannot have all of these three 0 at the same time. Let us take a look at this case. Case number 1. What if none of these is equal to 0? We need to analyze each scenario separately. X is not 0, y is not 0, z is not 0. So what happens here? From the very first fraction, 2x divided by x squared plus 1 is 2 lambda x. Divide by x, because x is not 0. What do you get? You get, let's see, 1 over x squared plus 1 equals to lambda. From the second fraction, 2y divided by y squared plus 1 equals to 2 lambda y. Since y is not 0, divide by y. Y is not 0. So you get 1 over y squared plus 1 equals to lambda. The same for the last fraction. 2z over z squared plus 1 is equal to 2 lambda z. Divide by z, since z is not 0. So what do you get? Get 1 over z squared plus 1 equals to lambda. So lambda, it's equal to lambda. So these fractions are equal to each other. 1 over x squared plus 1 is equal to 1 over y squared plus 1 is equal to 1 over z squared plus 1. What's the meaning of that? It means that x squared plus 1 is equal to y squared plus 1 is equal to z squared plus 1. Again, we can cancel 1, 1, and 1. So x squared is equal to y squared is equal to z squared. Take a look at your constraint. You get x squared plus x squared plus x squared minus 12 equal to 0, or 3x squared is 12, x squared is 4, so x becomes 2 and negative 2. So x is plus minus 2, y is plus minus 2, and z is plus minus 2. But take a look at your function. Your function has all y and x and z to the second power. So negative values, they don't impact the function. F at plus minus 2, plus minus 2, plus minus 2 is going to be ln of 5 plus ln of 5 plus ln of 5. We're just doing basic algebra. So it is going to be 3 ln of 5. This is your very first value here. Now we need to consider other scenario. Find the value, the output for the function, and compare those values. In the second case, suppose one of these variables is equal to 0. Case 2. Suppose one of x, y, z is 0. If taking x equal to 0, see what happens. The very first fraction says, hey, 0 is equal to 0. Okay, this is from the very first fraction. There's no issue there. Now go back to the second and third fraction. From the second and third fraction, you get these equality again, right? You get 1 over y squared plus 1 equals to 1 over z squared plus 1, or y squared plus 1 is equal to z squared plus 1, and cancel 1 and 1, y squared is equal to z squared. Now take a look at your constraint again. X is 0. So you get 0 plus y squared minus 12 equal to 0. So 2y squared is 12. Y squared is equal to 6, and y becomes plus minus square root of 6. Since z squared and y squared are equal to each other, you have the same scenario for z, plus minus square root of 6. Now f of 0 plus minus square root of 6 and plus minus square root of 6 becomes ln of 1 plus ln of 7 plus ln of 7. This is 0, so you get 2 ln of 7. Here we go. We found the second output of the function. Just circle this so you don't forget about this. If you plug in y equal to 0, you get the same values for x and z, plus minus square root of 6. And if z is equal to 0, you get the exact same value for x and y. Now, case number 3. In case number 3, assume two of these variables are equal to 0. Suppose now two variables are 0. We know that all of these cannot be 0 at the same time because of the contradiction. So we need to eliminate cases one by one. So suppose two variables is equal to 0. X is 0, y is 0. Check out the fractions that we have. 0 is equal to 0. No issue there. 0 is equal to 0. No issue there. Here, your lambda is equal to, we can take a look at this, is 1 over z squared plus 1, but it doesn't give me any meaningful information. I'm going to go back to my constraint here, and I see 0 squared plus 0 squared plus z squared is equal to 12. So z is plus minus square root of 12. Let me move this a little bit up. Perfect. So now z is plus minus square root of 12. My x and y are both equal to 0. I'm going to go back to my function. My function, f of 0, 0, and plus minus square root of 12 is equal to ln of 1 plus ln of 1 plus ln of 12 plus 1, which is ln of 13. ln of 13. So we have three values for our function. Three output values for our function. We need to compare these. You can use a calculator. Let us use a calculator. What is 3 ln of 5? This is approximately 4.83. 4.83. And 2 ln of 7. 2 ln 7. This is going to be 3.89. So this is 3.89 approximately. And finally, ln of 13. Let's take a look at ln of 13. What is that value? It is about 2.56. About 2.56. So which one is the minimum value? Which one is the maximum value? Just comparing the numbers. Your maximum value is going to be 4.83. This is your maximum value. The minimum value is this value.